Thomas & Betts 5060 box, like all electrical components intended for use in North America, is subject to rigorous testing and evaluation by Underwriters Laboratories, or all, to ensure it meets specific safety standards. These standards are designed to minimize the risk of electrical shock, fire, and other hazards. The UL White Book serves as a comprehensive guide to these listings, providing detailed information about the approved uses and limitations of listed products. When examining the UL listing for the Thomas & Betts 5060 box, several key factors come into play. Firstly, the type of materials used in its construction. The box is typically made of metal or non-metallic materials, and the specific material will influence its suitability for different environments. For example, a metallic box may be suitable for use in dry locations, while a non-metallic box may be required in wet locations or corrosive environments. Secondly, the box's intended application. The UL listing will specify the types of wiring methods that are permitted for use with the box, such as rigid metal conduit, electrical metallic tubing, or non-metallic sheath cable. The listing will also indicate whether the box is suitable for use as a junction box, a pull box, or a device box. Thirdly, the box's volume. The UL listing will specify the maximum number of conductors that can be installed in the box based on its internal volume. This is to ensure that the conductors do not overcrowd the box, which could lead to overheating or short circuits. Fourthly, the box's mounting method. The UL listing will specify the approved methods for mounting the box, such as to a wall, ceiling, or other structure. The mounting method must be appropriate for the weight and size of the box, as well as the anticipated loads that will be placed on it. Fifthly, environmental considerations. The UL listing will specify any environmental limitations on the use of the box, such as temperature range, humidity, and exposure to corrosive substances. It is crucial to select a box that is suitable for the environment in which it will be installed. The UL White Book will provide specific product category information that applies to boxes such as the Thomas & Betts 5060. This will include details about the tests the box has passed, the specific standards it complies with, and any restrictions on its use. For instance, the listing might specify the maximum voltage and current ratings for conductors terminated within the box. It might also detail the box's resistance to corrosion, impact, and other environmental factors. Let's consider some common scenarios. If the 5060 box is listed for use in wet locations, the UL listing will specify the type of ceiling fittings that are required to prevent water from entering the box. If the box is listed for use with non-metallic sheath cable, the listing will specify the type of cable clamps that are required to secure the cable to the box. If the box is listed for use as a pull box, the listing will specify the maximum size and number of conductors that can be pulled through the box. In addition to the UL White Book, the National Electrical Code, or NEC, also provides requirements for the installation of electrical boxes. The NEC specifies the minimum size of boxes for different applications, as well as the requirements for grounding and bonding. It is important to comply with both the UL listing and the NEC requirements when installing electrical boxes. Proper installation of electrical boxes is critical for electrical safety. Improperly installed boxes can lead to a variety of hazards, including electrical shock, fire, and equipment damage. Therefore, it is essential to follow the manufacturer's instructions and all applicable codes and standards when installing electrical boxes. Let's discuss specific aspects of box fill calculations as per the NEC, as this directly relates to the safe and compliant use of any electrical box, including the Thomas & Betts 5060. Box fill calculations determine the maximum number of conductors, devices, and fittings that can be safely installed in an electrical box. These calculations are essential to prevent overcrowding, which can lead to overheating, insulation damage, and potential fire hazards. The NEC provides detailed guidelines for calculating box fill, and it's crucial to understand and apply these rules correctly. The NEC specifies different fill factors for conductors of different sizes. Each conductor entering the box contributes to the total box fill volume. The fill factor depends on the conductor size, and it's expressed in cubic inches. For example, a 14 American wire gauge, or AUG, conductor might have a fill factor of 2.0 cubic inches, while a 12 AWG conductor might have a fill factor of 2.25 cubic inches. These values are specified in NEC Table 314.16b. All current-carrying and non-current carrying conductors that enter the box must be counted when calculating box fill. This includes HUTs, neutrals, grounds, and equipment grounding conductors. Each conductor counts as one conductor for box fill purposes, with the exception of equipment grounding conductors under certain conditions. Device yokes, such as switches and receptacles, also contribute to the box fill. Each device yoke counts as two conductors based on the largest conductor size connected to the device. For example, if a switch is wired with 12 AWG conductors, the device yoke counts as two 12 AWG conductors for box fill calculations. Internal cable clamps, fixture studs, and hickeys also contribute to the box fill. The NEC requires that these items be counted as one conductor based on the largest conductor size entering the box. For example, if a cable clamp is used with 14 AWG cable, the clamp counts as one 14 AWG conductor. The total box fill volume is calculated by summing the fill factors for all conductors, device yokes, and fittings in the box. This total must not exceed the maximum allowable fill volume for the box, as specified by the manufacturer and marked on the box itself. The maximum allowable fill volume for a box is determined by its dimensions and shape. The NEC provides tables that list the maximum allowable fill volumes for standard box sizes. These tables are typically found in NEC Article 314. If the calculated box fill volume exceeds the maximum allowable fill volume for the box, a larger box must be used. It's not permissible to overcrowd an electrical box, as this can create a dangerous situation. Let's consider a practical example. Suppose you have a 4" by 4" by 2.125" square metal box, and you need to install two 12/2 non-metallic cables and a single switch. The conductors include two HUTs, two neutrals, two grounds, and two equipment grounding conductors. The switch counts as two conductors based on the 12 AWG wire size. The total box fill volume is calculated as follows. Firstly, the conductors. 8 12 AWG conductors at 2.25 cubic inches each equals 18 cubic inches. Secondly, the switch. The switch counts as two 12 AWG conductors, which is equal to 4.5 cubic inches. The total box fill volume is 22.5 cubic inches. Now check NEC Table 314.16 to determine the maximum allowable fill volume for a 4" by 4" by 2.125" square metal box. According to the table, the maximum allowable fill volume is 30.3 cubic inches. In this case, the calculated box fill volume of 22.5 cubic inches is less than the maximum allowable fill volume of 30.3 cubic inches, so the box is properly sized. However, if you were to add additional conductors or devices to the box, you might exceed the maximum allowable fill volume and need to use a larger box. Remember that these calculations must be performed carefully and accurately to ensure compliance with the NEC and to maintain electrical safety. Always consult the NEC and the manufacturer's instructions for specific requirements and guidelines. Furthermore, when examining the UL listing of a box like the Thomas & Betts 5060, pay attention to the environmental ratings. Some boxes are rated for dry locations only, while others are rated for wet locations or even hazardous locations. Using a box in an environment for which it's not rated can compromise its integrity and create a safety hazard. For example, using a dry location box in a wet location can lead to corrosion and electrical shock hazards. Also, be aware of any specific instructions or limitations provided by the manufacturer. The UL listing may include notes or warnings about the proper installation and use of the box. These instructions should be followed carefully to ensure safe and reliable operation. In conclusion, understanding the UL listing of the Thomas & Betts 5060 box is crucial for ensuring electrical safety and code compliance. By carefully examining the listing and following the manufacturer's instructions and the requirements of the NEC, you can properly install and use the box in a safe and effective manner. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. Let's dive deeper into the grounding and bonding requirements associated with electrical boxes, including the Thomas & Betts 5060, as proper grounding and bonding are essential for electrical safety. Grounding and bonding create a low impedance path for fault current to flow back to the source, which helps to trip circuit breakers or ground fault circuit interrupters, or GFCIs, quickly and safely. The NEC provides detailed requirements for grounding and bonding, and it's crucial to understand and comply with these rules. Grounding refers to connecting electrical equipment to the earth, while bonding refers to connecting non-current carrying metal parts together to create an electrically conductive path. Both grounding and bonding are necessary to ensure that fault current can flow back to the source and trip a protective device. Metal electrical boxes, such as the Thomas & Betts 5060, must be grounded to provide a path for fault current. The grounding conductor is typically connected to the box using a grounding screw or a grounding clip. The grounding conductor must be sized according to the NEC, based on the size of the circuit conductors. Non-metallic electrical boxes do not need to be grounded, but any metal devices mounted in the box, such as switches or receptacles, must be grounded. This can be accomplished by connecting a grounding pigtail from the device to the grounding conductor in the box. Bonding refers to connecting non-current carrying metal parts together to create an electrically conductive path. This includes metal conduits, metal enclosures, and metal equipment. Bonding helps to ensure that all metal parts are at the same electrical potential, which reduces the risk of electrical shock. Metal conduits must be bonded to the electrical box using bonding bushings or bonding lockouts. These fittings provide a secure electrical connection between the conduit and the box. Bonding jumpers are used to connect metal enclosures and metal equipment to the grounding system. The bonding jumpers must be sized according to the NEC, based on the size of the circuit conductors. When installing electrical boxes, it's crucial to ensure that all grounding and bonding connections are made properly. Loose or corroded connections can create a high impedance path, which can impede the flow of fault current and increase the risk of electrical shock. All grounding and bonding connections should be inspected regularly to ensure that they are in good condition. If any loose or corroded connections are found, they should be tightened or replaced immediately. The NEC requires that all electrical boxes be properly identified with a permanent label or marking. The label should indicate the box's voltage rating, amperage rating, and other important information. This helps to ensure that the box is used properly and that it's not overloaded. In addition to the general grounding and bonding requirements, there are also specific requirements for certain types of electrical boxes. For example, boxes installed in wet locations must be grounded using a corrosion-resistant grounding conductor. Boxes installed in hazardous locations must be grounded in accordance with the requirements of NEC Article 500. It's important to consult the NEC and the manufacturer's instructions for specific requirements and guidelines. Proper grounding and bonding are essential for electrical safety. By carefully following the requirements of the NEC and the manufacturer's instructions, you can help to ensure that electrical systems are safe and reliable. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. Now let's discuss the importance of selecting the correct size and type of conduit fittings when using the Thomas & Betts 5060 box. The proper selection and installation of conduit fittings are crucial for ensuring a secure and code-compliant electrical system. Conduit fittings are used to connect conduit to electrical boxes, enclosures, and other equipment. They provide a mechanical and electrical connection that protects the conductors from damage and ensures a continuous ground path. The NEC specifies the types of conduit fittings that are permitted for use with different types of conduit. It's important to select fittings that are listed for use with the specific type of conduit being installed. For example, if you are installing rigid metal conduit, or RMC, you must use fittings that are specifically listed for use with RMC. There are many different types of conduit fittings available, each designed for a specific purpose. Some common types of fittings include couplings, connectors, elbows, and lockuts. Couplings are used to connect two sections of conduit together. Connectors are used to connect conduit to electrical boxes or enclosures. Elbows are used to change the direction of a conduit run. Lock nuts are used to secure fittings to electrical boxes or enclosures. When selecting conduit fittings, it's important to consider the environment in which they will be installed. Fittings installed in wet locations must be rated for wet locations. Fittings installed in corrosive environments must be made of corrosion-resistant materials. The size of the conduit fitting must match the size of the conduit. Using an undersized fitting can restrict the flow of conductors and make it difficult to pull the conductors through the conduit. Using an oversized fitting can create a loose connection that is not electrically sound. When installing conduit fittings, it's important to follow the manufacturer's instructions carefully. Fittings should be tightened securely to ensure a good mechanical and electrical connection. The threads of the conduit and fittings should be clean and free of debris. Conduit fittings should be inspected regularly to ensure that they are in good condition. Loose or corroded fittings should be tightened or replaced immediately. The Thomas & Betts 5060 box is often used with various types of conduit, including rigid metal conduit, electrical metallic tubing, armed and flexible metal conduit. Each type of conduit requires specific fittings to ensure a secure and code-compliant connection. When using rigid metal conduit with the 5060 box, you'll typically use threaded fittings. These fittings are screwed onto the threaded ends of the conduit and into the threaded openings of the box. It's essential to use a pipe wrench to tighten the fittings securely, ensuring a tight, waterproof connection. When using electrical metallic tubing with the 5060 box, you'll typically use compression fittings or set screw fittings. Compression fittings are tightened using a wrench, while set screw fittings are tightened using a screwdriver. Both types of fittings provide a secure and reliable connection. When using flexible metal conduit with the 5060 box, you'll typically use fittings that are specifically designed for flexible metal conduit. These fittings have a flexible sleeve that allows the conduit to bend without kinking or breaking. It's important to ensure that the flexible metal conduit is properly supported to prevent it from sagging or pulling on the fittings. In addition to selecting the correct type and size of conduit fittings, it's also important to use the correct tools for installation. Using the wrong tools can damage the fittings or the conduit, which can compromise the integrity of the electrical system. Always use the appropriate wrench, screwdriver, or other tool for the specific type of fitting being installed. Proper selection and installation of conduit fittings are essential for electrical safety and code compliance. By carefully following the requirements of the NEC and the manufacturer's instructions, you can help to ensure that electrical systems are safe and reliable. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. Now let's consider the use of the Thomas & Betts 5060 box in various applications, focusing on its suitability for different wiring methods and environmental conditions. The versatility of an electrical box like the 5060 is determined by its design, construction, and UL listing, which dictates the applications for which it is approved. The 5060 box can be used as a junction box, a pull box, or a device box, depending on the specific application. A junction box is used to provide a point where multiple conductors can be joined together. A pull box is used to facilitate the pulling of conductors through long conduit runs. A device box is used to house electrical devices such as switches, receptacles, and lighting fixtures. When using the 5060 box as a junction box, it's important to ensure that the box is large enough to accommodate all of the conductors that will be connected within it. The NEC provides guidelines for calculating the minimum size of junction boxes based on the number and size of conductors. When using the 5060 box as a pull box, it's important to ensure that the box is located in a place where it's easily accessible for pulling conductors. The NEC provides guidelines for the maximum distance between pull boxes in conduit runs. When using the 5060 box as a device box, it's important to ensure that the box is compatible with the type of device that will be installed within it. Some devices require a specific type of box, such as a box with mounting brackets or a box with a specific depth. The 5060 box can be used with a variety of wiring methods, including rigid metal conduit, electrical metallic tubing, flexible metal conduit, and non-metallic sheath cable. However, it's important to ensure that the box is listed for use with the specific wiring method being installed. For example, if you are installing rigid metal conduit, you must use a box that is listed for use with rigid metal conduit. The 5060 box can be used in a variety of environmental conditions, including dry locations, wet locations, and hazardous locations. However, it's important to ensure that the box is rated for the specific environmental conditions in which it will be installed. For example, if you are installing the box in a wet location, you must choose a box that is rated for wet locations. Boxes that are rated for wet locations are typically made of corrosion-resistant materials and have a watertight seal. Boxes that are rated for hazardous locations are designed to prevent explosions or fires. The NEC provides specific requirements for the installation of electrical boxes in hazardous locations. In addition to the general requirements for electrical boxes, there are also specific requirements for boxes used in certain applications. For example, boxes used to support ceiling fans must be specifically listed for that purpose. Boxes used in fire-rated walls must be installed in accordance with the requirements of the building code. It's important to consult the NEC and the manufacturer's instructions for specific requirements and guidelines. When selecting an electrical box for a specific application, it's important to consider the following factors. Firstly, the size of the box. The box must be large enough to accommodate all of the conductors and devices that will be installed within it. Secondly, the wiring method. The box must be listed for use with the specific wiring method being installed. Thirdly, the environmental conditions. The box must be rated for the specific environmental conditions in which it will be installed. Fourthly, the application. The box must be suitable for the specific application for which it will be used. By carefully considering these factors, you can select an electrical box that will provide a safe and reliable electrical connection. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns.